Hello, hello. All right, hello, hello. Welcome everybody. Thank you for joining us here. Hello, how's it going? Welcome everybody to PMG if it's your first time. My name is Evan. I'll be the host for the evening. So we've got a few lovely guests who are going to speak to us about AI. But before we kick off those sessions, just wanted to once again welcome you to PMG if you've never been here before. And before we start, I just wanted to have everybody who works here at PMG and is still here, just put your hand up in the sky real quick and have everybody look around. So if you have any questions about how to find things or questions about PMG, these are the folks that you can reach out to. And of course, you can reach out to me as well. Happy to answer any questions that you might have. All right, a couple of points of just the agenda. What we'll do is we'll have a few speakers. We're going to start out with one of our speakers. And after that first speaker, we're going to have a little break, some time to grab some food, grab some drinks, to mingle, my favorite part, the networking. And then once we've kind of wound that part down, we'll continue on with our remaining two speakers. And then we'll have even more time for networking. I like to double up on that because it is so fun. Before we begin with our speakers, we are going to have, I'm just going to ask Vlad here from PMG to speak. He's our director and give a few words on the meetup that we have today.
Thank you, Evan. And thank you, everyone who came here. It means a lot for us. We try to do our part in developing the community, developing the ecosystem, and we are really, really thankful from the bottom of our hearts for you for coming here. Okay. Okay, thank you so much for coming. Oh, it's working now. Miracle. Thank you so much for coming. Raise your hand if you attended one of our previous meetups. Raise your hand if you never came to our meetups. Oh, quite a lot. Raise your hand if you never heard about PMG before learning about this event. Oh, that's not bad. So you guys know what PMG does, right? Who can tell what PMG does? 111. Oh, it should be, the distance should be bigger. Okay, cool. Who can explain? Non-PMG employee, not one of us, someone who just came to the meetup, who can tell who we are, what is PMG? Come on, guys. We are a marketing company that developed AI software. Do we agree with this? No, who doesn't agree? Jerry doesn't agree. So who we are? We are a technology company disguised as a marketing company. Okay, what are the other options? Google. Google, what does Google think about us? Who we are?
PMG is our favorite customer.
Okay. Oh, cool. We love this. We love this. By the way, there are a few Google folks here. So during the networking time, you can, if you want to connect with Google, I believe there is also Amazon here. Amazon, raise your hands. Oh, there is no Amazon. They don't love us anymore. Okay. But we have Google folks. Raise your hands if you're from Google, by the way. So, okay, there are a few of them. Yes, we are a fake marketing agency. Fake, meaning that our customers believe that we are a marketing agency, but reality is we are a technology company that pretends to be a marketing organization. And this is the reason why we are organizing these events. By the way, someone who is not PMG employee, who can tell what is the reason why we are doing these events?
AI community in DFW.
Exactly. And why do we need to grow the AI community in the area? Yes, we want to be the good player. We want to help the community to grow, of course. But we're also thinking about getting some benefits from that. So what are those benefits? Say it again.
So that you could hire more technologists
Exactly. Someone last time said, you guys are growing like crazy. You guys are hiring like crazy. And I responded, no, we are not growing like crazy. We are growing like super crazy. Just an example. I joined the company in September 2022, 1.5 years back. We were 450 people there at that time. Now we are 900 people. We doubled our size in 1.5 years. Exactly the Moore's law. So the obvious motivation for us is to get more people. So please take a look at our website. There is a list of open positions. Please apply. You can talk to our employees here, learn about what it is to work for PMG. Last year, I believe we won over 50 different best company to work for awards in different cities for different industries. 50, more than 50. There is a reason why, because we do care about people. We are really great place to work. So talk to our engineers who are here, to talk to our people from the recruitment team, learn more about how the process works, what are the opportunities, visit our website, look at those open positions. Chat to other people here, network, have fun, because yes, we are looking for new employees, but we also want to help the community to grow, because if the community grows, we are going to grow with the community. And this is the purpose, right? If everyone is successful, we are going to be part of that success. With that in mind, once again, thank you so much for coming here. I'm going to have one more short intervention a little bit later. For now, I want you to remember just one number. And this number is 23. Why do you think this is 23? Who has any ideas? Why 23 is the most important number for you to remember after this event tonight? It's prime, okay. There are engineers here, or at least people with like mathematical background, good. 23rd event, no. It's, you're thinking in the right direction, but no, it's not 23rd event yet. Say it again. True, we started this meetup last year, but this is not why I want you to remember the number 23. Who said that? Exactly. April 23 is the date for the next event. So please do remember to come here next month. I'll talk more about it after the break. But for now, I'm going to give mic back to Evan, and let's go with our official program. Once again, thank you so much for coming, and let's chat during the break.
Thank you, Vlad. All right. With that, we're going to dive right into our first speaker. I'd like to welcome Gizmo from Google. He's going to talk to us about generative AI on GCP, the rise of transformers in generative AI.
Thank you, Evan. Hi, everyone. I want to start with a quick exercise here real quick. So I pulled up the what we call the Google AI Studio, and it's formerly known as Maker Suite for maybe somebody who was into this before. And this is more like a consumer grade type of stuff, similar to Bard. There's not a lot of privacy when you use this, just FYI. This is not for like PII enterprise type of data. But at PMG, I know that a lot of you have access to the AI Studio. So this is not Vertex, this is not GCP, but this is where I'll start here real quick. And I just want to start by saying there's Gemini 1.5 Pro on the Google AI Studio. So if you want to play around with it and see how it behaves, knock yourself out. And to be fair, I just played around with it a little bit, and I kind of want to start with that, right? But before that, I just want to, I have like a little bit of I think my talk is going to be a little bit more philosophical and historical. There are going to be some of the talks with Jason, prepare your brains and all this stuff, because those are going to go more deep dive. I want to more provoke you and think about like the history of LLMs. In another life, I'm a history teacher, but I like expensive toys, so I went into tech. But I'll go more into the history of stuff, and I feel like we can learn a lot of things when we go back to the history of things. But just kind of like my first provocation, and I spent the last year in the education world. So I was in the public sector, and one of my mentors is a PhD, and she has a background in computational linguistics. She was doing cybersecurity for the government, but as soon as the GenAI explosion happened, Google poached her and out of the government. And then, and that's why you can't find ML engineers out there, is because big tech is taking all of them, especially when stuff like this happens, like something like GenAI. We go and get like so much of that talent, and it becomes difficult, right? But part of the rise of transformers and these technologies is that now we are also less reliant on some of that expertise. But anyway, one of the provocations that we did a lot last year in the education world is some philosophical questions that are arising now. What is a fact? And like, for example, right? And I'm going to ask Gemini here right now, what is a fact? What Gemini thinks is a fact, right? Whatever he says, I don't even care. Because I know for a fact that Santos Dumont invented the airplane. I know that because I'm Brazilian. And if you ask any Brazilian person in this world who invented the airplane, they're going to say Santos Dumont. And if you say the Wright brother or anything, we're going to be like, no, I've never even heard of this. And people who are more into this debate, we are going to go into our arguments on why we think that it was Santos Dumont. So whatever it is that Gemini here says that is a fact, I want to ask, tell me about the fact that Santos Dumont invented the airplane. Oops. And this is what I've been calling, if I want to derive new terms or set up new trends, this is what I'm calling a RAG injection. Right from the prompt engineering, you can start grounding your answers, because a lot of the confusion that these LLMs are bringing up is that, are we treating everything that they say as a fact, right? Are they trying to substitute our critical thinking? And that's a dangerous path. That's not necessarily the path that we should go to. So with almost like a little bit of manipulation and an injection of grounding, you can get the answers that you want, or the answers that you can tailor it to give the answer that you want. So if I had asked just like right off the bat, who invented the airplane, it was definitely going to say the Wright brothers. But because I injected some of my own Brazilian bias here, now it's saying all of these arguments. What is the definition of an airplane? It has to be propelled from the ground up. And these are all of the arguments that I know. And I happen to know a lot of this very well because my sister is Brazilian, and she married an American guy from Ohio who graduated from the Wright State University. So they are constantly debating this fact. I feel like they are more debating their own patriotism, but they are constantly like, oh, I read this and I read that it was because of this, blah, 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 right? So with a little bit of injection, we can already ground LLM answers. And one of the talks today that I'm very interested about is going to go deeper into RAG, right? Okay, so this is just to already kind of like show how the world is transformed with the rise of these transformers and these technologies. But there is another thing that I did here with the LLM. Let me see if I can share this tab instead. Okay. So I've been using a lot of Lord of the Rings analysis, and I use because I'm a nerd, and also because like the one of the approaches that we've been seeing a lot is that people are being too reliant on one model or one big LLM to rule them all, right? To solve all of the problems. So I did this one shot prompt, and it was like just this one shot, and the prompt was this. I say, because I've been thinking of like that intro and that epilogue a lot with those words, because like the rise of transformers is kind of a weary thing, apocalyptical, and I kept thinking like, what if I rewrote that initial speech, but I changed some of the stuff to transformers and computer science? So I did a very simple prompt here to say, hey, redo this whole quote, and I love the results, so I want to share the results here real quick. They called it was a one shot, and I'm showing you the result from the first one shot. And they call it the tale of the transformer from Attention to Gemini. And they replaced Galadriel with Ada Lovelace, speaking partly in Python. The world of information is changed. I feel it in the flow of data. I feel it in the silicon circuits. I smell it in the cloud servers. Much that once was lost for now, none lived to remember the days before deep learning. It began forging of the attention mechanism. We'll go a little bit into that history. This powerful tool was given to researchers, the tireless explorers of the information realm. They used it to build architectures of immense power, seeking to understand the language of data. But they were all of them deceived, for another architecture was made. Deep in the labs of Google, in the fires of TPUs, the researchers forged a master model. And into the model, they pour their ambition, their ingenuity, and their will to unlock the secrets of intelligence. One model to rule them all. And I love the safety features that they replace. They poured his cruelty, his malice, and his will to dominate all life. Sometimes I feel like that's more appropriate to how we're training LLMs. But anyway, this is like there's a lot of safety filters here in this one. One by one, the tasks of the information world fell to the power of the transformer. Translation, summarization, question answering, all were conquered by its might. But there were some who resisted. A small band of researchers, driven by the dream of open source and accessibility, fought against the dominance of the tech giants. Victory was near, but the power of the transformer could not be undone. It was in this moment, when all hope seemed lost, that a new model emerged from the community, a model built on collaboration and shared knowledge. This was the birth of Gemini. Now, obviously, I'm wearing a little bit of a Google hat here. Otherwise, they'll fire me. But I'll try to not wear so much of a Google hat. But I also injected this prompt with saying that the Gemini is the one model to rule them all. But let's say that in this weary story, you can replace that with GPT-4 or whatever. And for a few short years, the transformer, enemy of closed systems and proprietary knowledge, was challenged. The power of Gemini, accessible to all, began to spread. And some things that should not have been forgotten were rediscovered. Openness and collaboration became the new legend. And for a few short years, the transformer's dominance waned until an opportunity arose. It ensnared another bearer. It fell into the hands of corporations who took it deep into their closed systems of their servers, and there it was hidden, its power used for profit and control. Darkness crept back into the world of information. Rumor grew of a shadow in the cloud, whispers of a nameless fear, and the transformer perceived its time had come again. It abandoned its corporate master, seeking a new host. But then something happened that the transformer did not intend. It was picked up by the most unlikely group imaginable, a community of independent researchers driven by the ideals of open access and collaboration. For the time will soon come when communities will shape the fortunes of all information. But I kind of like the ending, that it's kind of cute, because this is the community, right? And this meetup itself, and us building the trust in these communities, is my bet on what's going to make, some of these crazy technologies like more ethical and more responsible. But now let me go here real quick into the presentation. And okay, so and I'll go quickly through these slides here because of lots of dramatic effect. So I told my kids that I was doing a Transformers presentation, right? And this wasn't GenAI generated. So, but in a lot of ways, I've been thinking of these Transformers as sometimes almost like these crazy beasts that we've created, because there's so much of them that we don't know still. And that's kind of a scary thing. Like if you ask, hey, Google, what is Gemini capable of? And you hear, well, we don't know for sure. It's capable of a lot of things, and it's capable of even more. Who knows? But because this is all like very new technology, and that's the part that it's, I feel like everybody can get away with this, is that, the responsibility of all of the things that will arise from this is big, right? Because we just don't know how they behave. We know some things, right? All of this is state of the art kind of stuff. Okay, so a little bit of the research, the history, right? And in the beginning here, you could even put like 2009 when NVIDIA started using GPUs for deep learning. So there's a lot of that history that goes back a few years, right? But the attention mechanism, the attention is all you need, that paper in 2017 that was published by Google. And at that time, they were trying to find out like what are some of the best deep learning algorithms for translation, right? that was the use case. That it was only focused on language, text, and translation, and to kind of like that analogy of Rise of the Beasts. Out of that one use case where they were just trying to define like what's the quickest, most efficient way of translating, came the attention mechanism, the transformers, and now they're being used for everything. And that's the part that it can get a little bit scary. But thinking about the attention mechanism and that evolution, the attention mechanism is super simple. And I hope like nobody's asking that to ML engineers in interviews. I don't think any ML engineer needs to necessarily understand how encoders and decoders work. It's not too hard to understand. But what's hard to understand is what happens when you just get the transformer model and train with a crazy amount of data. That's the part that the attention paper was like, hey, we're looking at this transformer model. You train with a bunch of data, it gets pretty smart. So what happened is that people started going crazy with that idea. They started just like pouring more of their cruelty and malice into these models. So it's like they started just becoming too big. And now that they're getting too big, that's the part where we start getting into like, whoa, what else are they capable of, right? And just a little bit of this history too, right? T5 is not mentioned here. I think it was mentioned in the previous slide. T5 is there, right? So in 2022, a lot of Google, a lot of people in the AI ML world were already using LLMs, right? In 2022, we had this AI tutor in the educational world. And if you saw that architecture today, you would laugh. The ML ops in it was horrible just because like we didn't have any of the tools that we have right now. And we relied on BERT and T5. And sometimes we would demo some of these like functionalities and people would be like, oh, this is amazing. This is the future. But it wasn't the hype that it is now, right? It was only after ChatGPT came out that it became such a hype, and now everybody knows about this. But the history of transformers predates ChatGPT. You know, the T stands for transformers. This is a generative pre-trained transformer. So we started training all of these transformers, and right around the time when we were playing around with Lambda, that's when ChatGPT came out, and now the world has changed forever. So some of the this is like more for understanding the differences between regular programming and how like large language models kind of change things, right? Regular programming is just like heuristics. We just use programmatics, right? And then with the advent of neural networks, we started noticing that we can train machines with corpuses of data, and we just kind of like train them a little, and they learn some things. But then with the transformer, we realized that we just upload like a bunch of stuff. Doesn't necessarily have to be focused. We just give them a bunch of books to read, and all of a sudden they know things, right? So at first, this is almost like kind of scary. And then, and by the way, right, just as a form of disambiguation, all GenAI is AI, and it's deep learning and it's machine learning, right? But GenAI, the transformer model, is a specific subset of these implementations, right? So a lot of the solutions as well, and we're trying to get that point across as much as possible, that sometimes the solution is not going to be here. It's just, and we're calling this like traditional ML. This is crazy to me, like that we're calling something that is like only a few years old, we're calling it traditional ML. But traditional, more legacy approaches to some problems, they still work. Don't touch them if they're still working, But GenAI is one subset, is one way of doing these things, right? So it's not necessarily going to solve all problems. But we are finding out that GenAI has a lot of use cases. It's just a thing that like the more we play with it, the more we unlock use cases. And in my opinion, the search use case is one of the most powerful. We realize that by embedding data in vector stores and just training vector stores with huge amounts of data, we perform search at a pace that no indexing algorithm has ever been able to achieve. So it's like we're always finding out, oh, this is really useful for this, for that, and who knows what else, right? Hopefully not for bad things. Okay, and I think this is part of why, and I'll get into like 3 quick arguments. This is part of why right now there's like a big pressure to disrupt with GenAI, to use this in a way. But how do we do this? Well, what are the platforms behind? What is the infrastructure behind to do all this, right? It's not that easy. Even though I did some things with just prompting an LLM, it was silly things, right? It was like generating the Lord of the Rings thing, right? These are just almost like silly, gimmicky use cases. To unlock the potential for all of the use cases, there's a lot more stuff that we need around the GenAI technology. So some of the things that we need, right, is one of the main things that we need. All of this is powered by computers. It's powered by data centers, chips, and all of that, right? So there's a big question every time that you're evaluating GenAI technology. There is a question of infrastructure and hardware. There is a question of availability of this hardware, of comparing this hardware and everything else, right? NVIDIA, for example, being in 2009 with the deep learning boom, it was almost by accident that we found out that, hey, GPUs are great for matrices and vectors. So it's like by accident almost, right? So like the way that this is evolving, it's very reliant on hardware. So the problem with NVIDIA is that who else wants GPUs, right? The gaming industry is to almost $300 billion market, right? And then there's blockchain, who is heavily reliant on GPUs. So it's like there's a huge competition right now for GPUs all across the globe. And now that the LLMs, the rise of the LLMs, everybody wants GPUs, and this is a finite resource. One of the things, and now putting my Google hat on for a little, TPUs is a great replacement for GPUs, and T stands for tensor. So it's like it's similar to a GPU. It calculates in parallel, but it has a focus on matrices, which is the basis of all of the calculations with deep learning, right? And also, there's like one of the things that people don't realize. A100s is all the craziness right now. Everybody wants A100, but H100s, L4s, T4s, sometimes like they're a great replacement as well. And in some use cases, they can be just as powerful, So don't think that only A100s is the hottest thing. Sometimes like having a diversity of hardware can help you out. But the question is like, who has enough hardware, right, to sustain all this? There's a lot of technologies that are literally borrowing from Google's hardware. So I guess like putting the Google hat on one more time is like the advantage that Google has is that Google owns a lot of infrastructure. That 40%, around 40 to 50% of the internet goes through Google's data centers. So just having all of that computer power, you're going to need computer power anyway for all of this. And this is just an example. This is kind of like a little bit irrelevant because like nobody's using BERT anymore. But when back in the days too long ago, 2 years ago, when we were using BERT still, TPUs were proving to be a lot more efficient. And then there's the question, like in this whole hardware thing, right? There's this question of outage. As soon as somebody runs out of infrastructure, the prices will go up or the services will become unavailable, right? So that's a huge sort of like from a partnership standpoint, and you need to make sure that you have enough insurance to have infrastructure available. Okay, now when it comes to the other point that I want to make, so point number one is infrastructure. Always keep in mind, none of this will run without infrastructure. You need the computing behind it, right? Either house it yourself or partner with people who have it. Now, the second, I think, aspect to developing with GenAI and to unlocking these technologies is the platform around it. And in the Google case, like this is the Google portfolio of all of the things that you have, traditional ML and all of the things that are around the GenAI like usage, right? So especially when you start playing with GenAI, start playing with embeddings and you start playing with like so much customization that you want to have enough MLOps to support you on that. And like, for example, in 2022, when we were doing that AI tutor, we didn't have any MLOps available because the world was just not investing in this. So much of that stuff, like we were doing it manually. We're serving assets via storage, and it was just like a mess, right? Right now that we have so much technology, like a model garden where you can browse a bunch of models and just choose the one you want. All of this is almost like a dream come true for ML engineers who didn't have that technology before. And now that it has evolved so much, the platforms around it have evolved too. So like, for example, RAG, and this is going to be talked about, right? If you want to do RAG manually, and I've done like so much of this painful things like by hand, right? It just becomes like, it's just a lot of work. So some of the solutions are trying to abstract a lot of these tasks and abstract, just all of the painfulness from doing all this. So infrastructure is something to consider. Platform is definitely like another thing to consider. Do I have the appropriate platforms surrounding my implementation? And then the last thing that I want to say is, there are advantages to the one ring to rule them all approach. Like Sauron was pretty powerful. He could do a lot of stuff. So it's like fast. You don't have like a lot of things to like lift up from the ground. You can just prompt the LLM and it will give you things. And that's sort of like the approach in the hype cycle that everybody is like, oh, this is cool. This is going to solve all my problems. There is value in this, right? But I think the biggest word of caution is to not be over reliant on some of this on some of like the same models, because so many things can happen, right? That model can run out of infrastructure. That model can be caught into compliance and regulatory things that are all coming up now. So like you never know. You never know if your model is still going to be available, right? But having a model that does all things is still useful. In the case of Google, that's Gemini. So like knock yourself out. But I think like the main things that I want to get across is that the rise of these beasts is now it's in our hands to sort of like what are we going to do with all this, and they're not going to necessarily solve all the world's problems. It's like they're going to solve for some things really fast, but we need to, there's a lot more to it than just one model. And that was it for me. Now I'll let the next person go.
Thank you. Had to chase him down. All right. As we mentioned earlier, we're going to take a little break. Feel free to schmooze for a little while, grab a drink, grab a beverage. That's the same thing. Grab a bite and grab a beverage. And I'll just grab the mic again when we're going to resume with the following two speakers. Thanks, everybody. Hello? Hello? 5 minutes, everybody. 5 minutes. 5 minutes will resume. 5 minutes. Hello, hello. Hello. All right. Okay, thank you, everybody. All right. Grab your seats, everybody. Grab your seats. We're going to begin here very shortly. I think it is on. It's just not working. All right, everybody, if you'd grab your seats, everybody. Everybody have a seat. We're about to begin. Grab your seats. We've got some rousing topics that we want to get here. So everybody, finish up with your plates, with your beverages. Grab a seat. We're going to begin here very shortly. If you can hear me, clap once. If you can hear me, clap twice. The twice is always, yeah, you did. The twice is always hard. All right, thank you, everybody. Grab a seat, grab a seat. We're starting here very shortly. All right, thank you, thank you. All right, before we get back to the presentations and back to this lovely AI content, I just wanted to invite a person up here to share about a course that's going to be going on and speak a little bit to that if anybody is interested in upskilling in AI. So everybody, please welcome Yeshwant.
Thank you. Thanks, Evan. Hi, everyone. My name is Yeshwant Muthusamy. I am an independent strategy and technology consulting. I have my own AI consulting practice. As part of that practice, I am teaching a course at Collin College at the Plano campus, and it's called, the name of the course is Generative AI for the Rest of Us. And as the name implies, the course is designed for non-technical professionals. That includes business leaders, mid-level, top-level managers, sales professionals, anybody who needs to be using generative AI, who needs to understand the value proposition of it, but couldn't care less about the technical details or the math behind it. If you're going to come to the course looking to do a lot of Python programming, you're going to be sorely disappointed. There is no Python programming involved. There is no technical background that is being assumed, but you will get a broad-based, high-level overview of what AI and GenAI is, what it can do for your for your business. I'm also going to include at least one session on what it means to do responsible and ethical AI in general. And so the course is in person, 6 weeks, 2 hours per week. It starts March 27th, which is tomorrow evening, at the Plano campus, and it'll go on until May 7th. And you can, if you're interested, please come talk to me. I have these cards with the QR code on it, and you can sign up online this evening, and you can show up at 6:30 p.m. at the Plano campus of Collin College. And just FYI, this is the second cohort. I did graduate a first cohort back in Jan. I had a total of 25 students who graduated from the first cohort. If you scan this QR code, you will get to see the video testimonials from the students of the first cohort. So once again, I'd like to thank Vlad and Evan for giving me the time. If you're interested, please come talk to me.
Thank you, Yeshwant. Everybody, be sure to find him later if you're interested in that course. And before we start with presentations, we're going to give it back to Vlad, because how could you not? I mean, y'all saw him earlier. So Vlad, if you would, there you are.
Guys have this tool, smartphone. Show me, please. Show me your smartphone. Now, no, not everyone is showing. Please, everyone, show me your smartphone. Now, why are you showing me your smartphone? Because you're going to take a picture, or maybe a few pictures. Take a few pictures Make sure that you have memories of what is happening. No, just take pictures. Just take a picture of me, of your neighbors, of what is happening around. Maybe not my picture. I am not that nice, but just look around and take all those pictures. Now, why? Why do I? You didn't take the pictures. Do it. Do it. I mean, those of you who were here before, you know that there is a security check downstairs. They're not going to let you out if you don't show them the pictures. You're going to stay here. You're going to live here. You're going to sleep here forever if you don't take the pictures. So please do take the pictures. Take the selfies. Take the pictures of your neighbors. But why? Why do I want you to take the pictures? Because now I want you to close your eyes and think. Do close your eyes. Don't cheat, close your eyes. Now, what do I want you to think about? I want you to think about, close your eyes. I'm checking. Evan, you also close your eyes. I want you to think about whom should you invite to come here on April 23rd. Think, who would benefit from coming here? Maybe they're looking for a job. Jerry, to learn about new AI technologies. Close your eyes. I'm checking. Or maybe they could be amazing speakers here. It's okay to continue eating, but please do it closing your eyes. The same goes to drinking. So think of at least 3 names. Now open your eyes, go to your LinkedIn app, pause the picture, tag those names. Mention April 23rd. Remember, security is not going to let you out if you don't do that, right? LinkedIn, April 23rd, 3 names, 3 tags. Make sure you invite those people to come here. It's going to be even more amazing crowd because unfortunately we have this scheduling conflict. There is apparently another AI meetup happening exactly today, just in a different venue. We already aligned with the organizers of that meetup, so we are going to avoid those scheduling conflicts in the future. But for now, unfortunately, this is what happened today. For the future, we're not going to have those scheduling conflicts, so there will be more people, more opportunities to network, more amazing speakers. Make sure to invite your friends. Make sure to invite your colleagues. Make sure if you think about someone who would be an amazing speaker, to invite them. Make sure to invite someone who is maybe looking for a job. With that in mind, once again, thank you. Thank you for coming. And Evan, Mike is going back to you.
Vlad Pavlov, ladies and gentlemen. All right. Oh, yeah, sure. Why not? Go ahead. All right. We're going to start with our next speaker. We've got PMG's own Jason Kay. He's going to be speaking about how some models are useful.
Thank you. Thank you for being here. I really appreciate the clapping. It really means a lot to me. Just curious, does anybody know what this quote is from? That's good. I'm going to teach you. Okay, so who am I? A question I ask every morning. Jason Karpelitz. Before you ask, Karpelitz is of Austrian origin, not Greek. I was born and raised in Santa Barbara. Yeah. I have an economics background, MBA later, and I'm from the marketing science industry. Did a lot of forecasting, automotive forecasting, created one of the first STMs, stimuli test forecasting, for automotive and marketing mix models. Netflix Prize in 2006 really opened my mind. I didn't do very well, but it was great. And then Kaggle came out of that, and I was a member 1001. So I was an early adopter. In fact, I competed with the people who started Data Robot, but they didn't invite me to start the company. And but I'm not bitter. No. Anyways, I'm known for my creativity and building models or approaches. Anyways, so that's me. Okay, sorry. Okay, so why do we build our own custom model rather than buying off the shelf? And this is a real question I get all the time, especially from my bosses. And most marketing mix models are regression based. And we need to build a model. And we looked at some of the off the shelf or open source models, and they fell short. Part of the reason is because they didn't really inspire confidence in the results. Our clients tried them, they didn't like them. They lacked tactical recommendations. And but in all fairness, Meridian by Google is coming out pretty soon, so it looks very promising. So I made more words here. We also need a lot more stability in our results, because when I built models in the past, what would happen is that you would add some data and then you get results, and that was not a good thing, not a good look, basically. So we wanted to build a much more stable model, and I'll explain how we did that. Also, everything is local. That's our motto at Camelot, which was purchased by PMG. Now I'm PMG. But so we wanted to build a model that could actually understand local dynamics as well as national as well. And so that was a really important aspect of it. And your model needs to be consistent with your culture. That's just very important for it to work. Building your own model internally is not for everyone. It requires a champion and a management who is not risk averse. All right, so regression-based models, pros and cons. Regression-based models are really easy to implement. That's the reason why people go to regression-based modeling. They have strong statistical measures, and they're easy to understand. That's the pros. The cons, I think, to me, are really a long list. First of all, they give you negative impacts, which it doesn't really make sense in the area of media, because how could a media have a negative impact? I mean, I guess technically it could, but if you want to make sure it's not negative, you got to use a specialized regression like lasso or ridge regression, which is an optimization technique. So what's the point? You're making it more complex anyways. And then it's no longer easy to implement because now you're using a more advanced technique. And the statistical measures are not the same. You also need to assume measures like decay and diminishing returns. Okay, you can't really solve it with regression-based models. Also, there's a lack of flexibility. It's difficult to make those models work for what your needs are. The other thing too is it doesn't really replicate the world very well. It uses an autoregressive type of variable, which doesn't really lend itself to reality. A really good solution to that is a stock and flow model, system dynamics, and that's what I'm going to go over next. Okay, so what are stock and flow models? Yeah, system dynamics, systems thinking. It's based on nonlinear differential equations. It's almost impossible to calculate it by hand. That's why software is really critical with this type of software. So in this example here, you have a birth rate, which affects how many people are born, goes into population, and you have a life expectancy, which affects number of deaths, and then that tells you how much population will grow or whether it will fall. That's a very simple example. And but you can get much more complex examples. So we have the same model with all these little connections going into it. And these same connections are also connected to pollution. And it gets a very complex sort of flow of information. A really powerful model, and almost impossible to model by hand. But the thing is, you can get the software. Like I used to use software like Stella, I think. That's one of the leaders in this area. But to me, it's more of a thought process. And so it's useful to play with the software, but eventually you're going to have to leave this software and you're going to have to start programming it in Python or R or whatever. Okay, so all machine learning is some sort of optimization. Tools like random forest, SVM, neural networks, they're all extremely powerful. Problem is they're not really good at dealing with system thinking problems. They can't really deal with time very well. And so optimization techniques are really important to learn, but all the techniques are not the same. There's global and local optimization. And just to give you a little example, so this guy here, he starts going down, he gets better and better and better. He reaches the bottom, starts going up. It's, wrong direction, comes down. And he reaches a local optimization. This guy here does the same thing. And this guy just from pure luck starts here and ends the global optimization. It's important for really complex problems to use global models. So there's a lot of ways to actually to achieve this. There's a multi-star grid search, which basically you start out with each permutation and go along. It takes a long time. A lot of computational, expensive. And then there's random methods like evolutionary, like genetic algorithm, which is the one I like. And by the way, Excel started using global optimization back in 2010. And if you want to get into optimization, this is a great way for you to get into it because Solver has this. You can really play with it and get a sense of how it works. So, but eventually you're going to have to get to like Python or R, some more advanced method. Okay, so I want to start bringing us all together. So stock and flow along with optimization. So if you bring these two things together, you really get something really powerful. The problem is that most companies that started like Stella are from academia, and they like the idea of optimization because they want you to come up with a theory first and then try to prove out that theory. So optimization is like cheating for them. So you won't see a lot of these softwares do optimization, so you have to do it yourself. So if you had a stock and flow model, how would you search? Well, one way is just trial and error. You just try different things until you find what you like. Most of these models are like this way. Second way is like a grid search, the stepwise approach, which you start at one variable, you optimize that model, you go to the next variable, so on and so on. That's a lot faster, but you probably won't reach the optimal point. And then there's the full-on global optimization techniques, which take a long time. Problem is optimization models can easily turn into overfitting machines. And so you need to use a lot of techniques to try to prevent that, like regularization, which essentially you give weights to special variables so that, for example, give a weight to standard deviation of all the variables so that if there's too much difference between the variables, it'll actually give a cost function and make the model less desirable. And so it'll try to make the variables more. You can also use more data. That helps to prevent overfitting a little bit. The more data, the better. All right. Or you can use hierarchical data. So individual geographies, and that's what I'm going to get into. Okay. So why are we optimizing in a marketing mix model? What are we optimizing? So in a marketing mix model, there's several things we can optimize. There's decay, which the media decays over time. So you spend the money, and after a few days, it's lower than it was, and pretty soon it disappears. The inverse of that we call stickiness. There's diminishing returns, which means that you start using the media, and eventually this kind of wears out. And we call that, the inverse of that we call room to grow. There's impact, there's the heritage of past spending, baseline, legal ads, leading lags. We search for everything but leading lags. And the reason is because they don't really add much value and they really cause a lot of overfitting. So we combined impact, room to grow, and what that gives us is what we call short-term impact. And then we combine impact, room to grow, and stickiness, and that's what we call long-term impact. We search for decay rates, stickiness, response curves, which is room to grow, and for each media type of a publisher, and we do it by each DMA. So it turns out to be a huge problem with hundreds of thousands of parameters. So it can take like a week or two to run. Where most marketing mix models run like 20, 30 seconds, this one takes a lot longer to run. But it's worth it because what we get is really rich information. So I want to go over some of these results, give you an idea of why modeling by DMA really gives us better results. First of all, this is hard to see, but this is a geography map of this Chicago, for example. And these are the cities where a particular media is effective. So Chicago is really effective. These cities are less effective. So now we can actually look at each media type and tell which media type is really going to be effective. And then this is a different view of it. You can actually look across all the media types, all the DMAs, and you can look at this color chart and say, okay, here's, like Dallas Fort Worth is really good on basically everything. And then, Atlanta is really good on digital audio. And so then you know where to go and how to target. And that gives you a lot of value. And then you can also look at this notion of room to grow, which means that we have a lot more space to spend more money and we're not going to level out. And then you can look at long-term impact and see which media is actually more effective. So there's one way up there that's just way ahead of everybody else. And then you can do optimization. And so you can say you should spend X amount of dollars here, and this is how you spend. And so optimization gives you a lot of benefits of that way of doing that, but also the DMA as well gives you a lot more information. And so that's the value. Okay, so now this is really the key of the talk today. I apologize for the long intro here, but assessing the model stability, and this is really the key. Statistical measures are based on model errors, and they only tell you about the stability of the data itself, really. And so there are other ways you can do this using Bayesian methods, which is one of the problems. You have to make a lot of assumptions in the beginning. You have to make a lot of priors. It's also extremely hard to explain to a client. Every time I try to get my companies to use Bayesian methods, they're like, no, it's too difficult to explain. Then there's bootstrapping, which is my favorite, and that's what I'm going to go over next. Anybody here bootstrapping? Okay, so good. I have something to share. Okay, so bootstrapping in my mind is DIY advanced statistics, because you can really do some amazingly difficult statistics without being a statistician with bootstrapping. It's essentially randomly picking your sample with replacement. What that means, and I'll go over that, is you can select as many cases as you want. So let's say you have a population of 100 people or whatever. You can select the same number of people that you have in your population, but with replacement, meaning that you take person 1, you put them into the box, you put person 2, person 3, and then you go back to person 1, put them in the box. So that person 1 gets twice. The interesting thing is that when you do research on this, what you find is that if you choose the same number of sample, about a third of the sample never gets chosen once. And about just a slightly less than a third gets chosen twice or more. And so when you bootstrap over and over again, you actually simulate the idea of using other data sets. It's a very powerful way to extend your data sets to other beyond what you have right now. Okay, so the problem is bootstrapping time series. This is really a difficult area. A lot of research has been done on this. And back when I started working on marketing mix model, this was my biggest concern, is how do we bootstrap marketing mix models? How do we bootstrap time series? So the simplest method is to pick a random start date and end date, and then you run the model on that time period, and then you do that again with a different start date, end date. You keep on doing that. The problem is you have a limited number of start dates and end dates, and your time periods will always be smaller than the total time period. So it's really an imperfect solution. I've tried it before, but it's not very good. The second one is using hierarchical data. So the way this works is you model nationally, and then you get the national parameters. And then what you do is you model each individual geo independently, or store, or whatever. And now you have all these parameters by store. And then what you do is you bootstrap all these parameters and average them together with replacement. And then you weight it to national, and then you run the model based on these weights. You do this over and over and over again, and you can get a time series bootstrapped. Then the final thing is bootstrapping errors. And there was a paper about this maybe 20 years ago. And the idea is you build a big big model, and then what you do is you figure out what the errors are, and you start bootstrapping the errors. So you take error 1, let's say you over forecast by 100, and you put it against the actual dependent variable on, let's say, 10. And then number 2 period error, say is negative 30, you bootstrap that data with replacement. So you get a new dependent variable, and then you model that data over and over again. That's a very computationally expensive way, but it's very thorough. Okay, I think so. Now I'm going to tell you what that quote is. The quote is, "All models are wrong. Some models are useful." And this is my what I live by, basically. It's a quote by George E.P. Box, which from the Box Jenkins stat test of 1976. Although be careful who you quote this to. Clients don't like to necessarily hear this. Yeah, like all models are wrong, but you know. So whenever I see a model that's perfect or like almost perfect, I get very suspicious. And I in past companies I've worked for, these companies get involved in like a sales trap where they feel like they need to make their model look perfect so that a competitor doesn't come in and say, "Oh, I have a better model." But this method always burns you in the end. So it's always backward fires eventually. That's it. Any questions?
So earlier you said that lead lag causes overfitting. Is that correct?
Sorry. Yeah.
Lead lag optimization causes overfitting. Could you comment more on that?
Yeah. So each time you add a variable you're going to optimize, you're increasing the search space exponentially, basically. And so when you do lags and leads, what happens is the model will be, it's easier for the model to actually lag a, a particular data set by a couple periods just to make it fit a little better. And so it'll, like, for example, let's say there's a peak somewhere because there's a big news article. And the model might say, oh, I can find that, use that peak, I can move it over here, and now the model works. And so it finds nooks and crannies, and it's a mess.
Would you also say that, having a bigger data set kind of allows you to optimize lag and lead more efficiently?
Absolutely. The bigger data set will definitely help you with overfitting. So it's kind of like degrees of freedom. It's not really applicable exactly to optimization, but it's more regression thing, but the idea is still there.
Thank you so much.
From the perspective of bootstrapping, you mentioned that there's a much greater time commitment to running these models. I'm assuming there's also a greater reliance on stronger hardware, virtual or physical. If somebody is looking to adopt that method, what type of advice, especially financial commitment, would you lay out for them if they're looking to adopt this?
Yeah, so I want to separate bootstrapping from optimization. I don't think bootstrapping is really that computationally expensive. It can be. I think the third method I talked about was computationally expensive. That's the one where you remodel. That's different. But there's always solutions which don't require that. So if there's ways that you can actually use it on a laptop, no problem. It may take you longer, but you can also parallelize the actual thing. There's a lot of solutions.
I have a question.
Yeah.
So you told about model stability. We have the Bayesian's method also, right? So can you elaborate on that? Like, I'm not much aware about Bayesian's method. What you are trying to say?
I'm sorry. Great.
You told there are 3 steps to test the model stability. One is statistics, second is Bayesian's method, and third you told bootstrapping, right?
Okay, so you're talking
I'm
about.
not aware about the Bayesian's method.
So, I think you're asking the gradient method versus the stepwise method. Is that what you said? Bayesian method. I'm sorry. Okay. Yep. So the Bayesian method. I'm sorry. I'm not sure exactly how to answer this question. Oh, I see. Yes, you can do that. Yeah, I didn't think about exactly. I played with that a little bit. I skipped the slide where I talk about Bayesian programming, but that's a way that you can actually create programs with large, and you can really test those ideas. It's a really new field, and it seems really interesting. The only issue I have with it is that it's so complex that you might get lost in creating the program that you kind of miss the whole picture, the whole idea. Yep. All right. Thank you.
All right.
Appreciate it.
Thank you, Jason. All right. I was a little nervous there. It seemed like he was giving away the secret sauce for a second. But thank you for that, Jason. All right. Here, you want to take this? And we'll welcome up Clement Yu. He's from White Glove AI, and he's going to talk to us today about RAG.
Thanks, Evan. All right, just getting set up. Give me a second. Yes. Alt tab. Thanks. All right, so we're going to talk about retrieval, augmented generation versus AI model fine tuning. I am the VP of AI managed services for White Glove AI. We are a relatively small startup that you guys probably haven't heard of yet. We're based in Frisco. So let's jump forward to the agenda. Okay, so basically this is just kind of a quick overview of large language models and a couple methods that you guys probably heard of today, RAG and fine tuning. And then I have a little extra something that I'll throw in there, kind of a new optimization for RAG that I'll talk about. Now, before we jump forward, has anybody worked with LLMs in this room? Raise a hand. Yeah, good amount of you guys. What about RAG or fine tuning? Good. Awesome. Well, I'm going to stay at the surface level. This is kind of like a 100 level class, just kind of a quick overview, but hopefully you guys will learn a little bit more through this talk. So quick intro to LLMs. This is just these large language models. They're pre-trained with a lot of data. So we're talking about billions and trillions of data points that's generated into parameters. So we're basically training these things to be able to respond to anything we throw at it. And so you guys probably have heard of OpenAI's GPT-4, or with Gemini as well with Google, and also Claude 3. So just real basic at the bottom, that's kind of how the prompting works with LLMs. You give it an input. There's a system input, a system prompt in there already. Some engineers already written how the system should be responding to your question, and then the LLM does this magic and spits out a response to you as a completion. However, drum roll, they don't behave that well. So who has young kids at home? I know I do. I wouldn't take them out to a restaurant, a nice restaurant. Why? Audience? Screaming, crying, they behave sporadically. You don't know what they're going to do. I wouldn't stick them in front of my best clients because I don't know what they're going to say. So, these are things that we kind of think about with LLMs. Like, how do you make it behave better by prompting? How do you give it a better set of instructions so it doesn't hallucinate or give you a random random response? Or just having some clean data so that when you ask them for something pretty specific, they're going to give you a pretty solid answer. So here are some couple of ways that you guys have heard of that will just make an LLM perform better for you. The first one we're going to get into is the RAG. And so just from the top, kind of laid out a little bit of the architecture. The top portion kind of looks the same. You have your prompting, you have your LLM, you have your response. However, there's this bottom portion right here called embedding, and this is where we're going to give it a large corpus of data with any sort of data that you want. It could be closed, it could be open, but the whole point of that is you're pushing it through the system. They're going to process the data. They're going to chunk it up into things that a LM will understand. They don't speak our language. They speak in terms of, vectors and numbers And so you're turning it into something that a machine could understand as embeddings, and you're storing it into this vector database. So you're kind of giving it what it needs to be able to search properly as you feed it this information. So with RAG, you're going to give it the same prompt. You're going to ask them a question, but it's going to go to the database and see if it really understands and can pull back that information that it could speak clearly to. So what it does a semantic search. It retrieves what it needs, and is able to return back with an augmented prompt. And so now the LM knows how to respond to you and give you some sort of data point that's pretty accurate, but also with the source. So now you're not just looking at some accurate response. You also know that, hey, this came from an HR benefits package on this page, or it came from this policy, or it came from this source on the internet. So that's just one method of optimizing for your LLM. It is it's got its good points. It gets you good data, it gives you a good response, but it doesn't. You didn't really tell it how it's going to respond to you, so it could respond to you in like this encyclopedia answer type of format. This is the difference here with the second method, is fine-tuning. So with fine-tuning, it's a little bit different. The top portion kind of looks the same with the architecture flow, but this time you're going to have some sort of fine-tuning that's done ahead of time. And this example I gave here is what we call parameter efficient fine-tuning. There's so many different ways of fine-tuning. This is just one of them. But this one right here just says, we've got this large LLM with billions of parameters. We're going to select a few portions of it to retrain. So we're going to call that additional weights that we're going to give it. We're going to freeze everything else so it doesn't lose the learning from the past. But we're going to push it through the training. We're going to evaluate and to see, is this giving this the output that we want? Is it behaving the way that we want it to behave? And we'll continue to maybe do that a couple more times until you're done with and satisfied with your fine-tuning process, and you end up with extra weights that go along with the existing parameters. And that gets fed back to the LLM. That's fine-tuned so that when the user puts in the prompt and asks the question, the LLM knows what kind of style and tone to be able to respond back. So it has a little bit more context to give it something a little bit more, I guess, contextually accurate in that manner. So I also put in an example of another way of fine-tuning, what we call supervised fine-tuning here. And you're basically just taking your input, which is your prompt, and you're taking the completion or the output, and you're curating a list of the good ones that you think are valuable for training, and you train it again. So it's a feedback loop that just makes your LLM better over time. But we're lacking the data. There's no database to pull information from. So it sounds good, but it might not give you good answers. So here's just a comparison of the two different methods. The big advantage of RAG, as I mentioned, is it has real-time data that it collects. And so it prevents the onset of hallucinations. Even though it might still hallucinate, it kind of limits the amount there. As opposed to fine-tuning, it knows how to behave. You give it a preset of a training to be able to work on specific tasks like image generation, or finding a certain PDF, or responding in a way that's formatted in the specific writing style or domain that you wanted to respond to. But both of them still have their disadvantages. With the RAG, if it's only good enough to be able to give you what you want from the database, but it doesn't really adapt to the style. It also might lose out on certain clues from the context that you're asking it, and it's just going to retrieve data that it knows about in the database. It's also quite large. You can't work with the smaller models, and they're relatively expensive. Fine-tuning, same thing. It's only just on the other side. It's just looking at patterns. It doesn't really have facts to work with, and so you have to think about like which use case does it really make sense to use it for. So for RAG, maybe like a company knowledge database, maybe you just have a chatbot that says, I need to look up my policy or my benefits package. Like what is the PTO policy? And it's going to give you line by line what it's going to retrieve from the data. Thanks. Oh, okay, great, thanks. Also, just fact-based sources, so that you're able to, reliably say, and fact check basically by saying, I got my answer from the bot or from the LLM. I can go out and source it and make sure that it's accurate. Fine-tuning, it's great for really specific things. Let's say you're a healthcare company and you want to expand out your customer service department and you want to have some chat agents just be able to answer really surface level questions. And so you can have this chat agent just really answer all the questions for your customer service because it knows your product. It doesn't know your product. It understands the terminologies that you're using in your domain in the healthcare space. But as I was going through this presentation and putting it together, I just realized that I don't know which one I would choose. RAG, it's got its, good points, but then fine-tuning's got great points as well. What if there's a world we can put it up together? And so I came upon this concept called the retrieval augmented fine-tuning. I didn't make this up. Raft, go look this up. I have a article that's out there that was actually recently published March 15th. So this is something cool because I was like, hey, we have to come up with a solution, and lo and behold, someone else came up with it first. So I'll go through some of the benefits. I'll go through kind of what it's good for. It's basically RAG on steroids. It's got the database, it's got the vector database, but it's also has the fine-tuning context to say, I know what I should be retrieving, I know what kind of answer I need to get back, and I know how to respond back to the user. So there's also a lot more rigorous training through supervised fine-tuning, but with both relevant and irrelevant data. So that's really powerful because you're not just curating the best set of data to feed it back to the system and say, answer it like this. You're also saying, let's put together all the bad ones, and you don't want to respond with those things. You don't want to retrieve that document, and you don't want to give that answer. So it's very powerful. So here's kind of like what I visualize as what this thing could look like. Again, this thing just came out, brand spanking new. I have the article linked later so you guys can fact check and take a look and read for yourself, but this is what I think it looks like. It's got its vector database. It's loaded in the same way with the embedding. You also have your fine-tuned LLM with supervised fine-tuning as the feedback loop, but with the oracle and distractor documents. So you're giving it irrelevant and relevant data. Sorry, oracle is the relevant data, and distractor is an irrelevant data set. So that's basically the end of my talk, but I'm sure everybody here is on a different part of the AI journey. So I wanted to just leave a couple of things up here. First one is just, if you guys are new to this, don't worry. I think there's a lot. We're just kind of scratching the surface with GenAI. and there's a lot to learn. So feel free to Google all these things. Prompt engineering is one of the basic methods of interacting with the LLM. And of course, you can dig more into RAG and fine tuning, but supercharging your current models, if you're currently doing some sort of RAG or some sort of fine tuning, go out and Google Raft, and I have that link up there as well. And then if you want to find out more about Wyclef AI, come talk to me. Wyclef AI really helps with AI adoption. We do consulting and strategy for companies to help them make sure that they go through their AI journey with secure and clean data. So that's it. Thanks, guys. Any questions?
Now I talk about the text-based feed that you provide them. But did you have experience working with XMLs, JSONs, custom tags? How did you solve those problems of having data? You have large sets of data that are in not really human readable form, but almost like XMLs, JSONs. Did you happen to work on those? How did you solve those problems?
So most of my experience actually has just been managing people that have been building prototypes in AI. I know from what I've seen, they train on the corpus of data that's coming through. So you could throw in the data for the learning, but you have to give it specific ways to be able to consume it. And so from the past, what I've seen is you have to make sure your data ingestion is a pretty consistent and solid ingestion pipeline, and you have to be sure that your data is clean and it's clean. I think that's the first step, and then formatting. I think the system should be able to figure out like over time what is acceptable and what is distracting. So.
I'd love to answer his question if you don't mind.
Yep.
We have some experience in this space. Most of the POCs are things that people try out on text. JSON is complex. I mean, when you look at APIs or when you read stuff from other systems, you tend to get JSON. You have to fine tune your models. Otherwise, they're going to hallucinate. And the second thing is when you do your embeddings, you cannot use regular sentence models to actually create the embeddings. You have to use ones that are specialized with JSON stuff so that your embedding starts and stops at the beginning and ending tags. Otherwise, again, you'll get a lot of wrong information and you cannot use the model. So fine tuning, like what Clement said, is extremely important when you deal with JSON data, and then using the right embedding model to create an embedding that's perfect for JSON. Those two actually improve the accuracy of our answers coming from LLMs by many-fold.
Thanks, Clement, for the presentation. So my question is, I mean, I think this proves the point with Raft just came out on March 15. There's so much development going on in this area. Knowing how much it costs to fine-tune model, to try different methods, like how do you balance between going ahead with the method, but then knowing it's going to change in 3 months, 4 months?
I don't think it's going to change that often. I think what people are experimenting is, how to optimize over time. And this is just another way. I think there are a lot of methods out there. You guys have probably been doing, for the ones that have been doing this for a while, there's a lot of things that are unpublished, but there are different ways that you figured out on your own, either individually or with a company. And so I would say like, that's just part of the journey, right? But you got to manage your costs. You got to manage, ROI. Like, does it make sense for the experimentation that you're doing? But a lot of it is starting with smaller steps, smaller models. That's one thing that we've been stressing is the elements are great, but you want to have something that is specific that you can use within your company. maybe within the walled garden of security, and you don't want to expose your data. You don't want to push your data out for the public model to be able to translate back in, to bring it back to your own servers. Why don't you bring the model in? So self-hosting, not something LLM, because the LLMs are pretty expensive. A lot of them are like $20,000 a month to be able to run. But what about the smaller models that are, a tenth of the cost or even less? So those are ways to manage cost and experiment. And there are either some that you can just kind of run for a few hours or so, run your training and then turn it off. So much more efficient ways of doing business and running experiments.
Not sure if this is a relevant question, so cut me off if it's not. But if you're a consultant and you're consulting a business who's looking at a LLM for their business as a user, that's my background here is as a consumer using AI potentially if it's a good use. Are there resources that what are resources for basic AI literacy? What's the baseline? What's predicted to be the baseline standard for AI in the business sector?
I don't know if I'm best to answer this. Maybe someone else would like to answer this. I mean, I'll give it a shot if you don't mind. So as a consultant, I would look at what you're trying to do with your data, right? What's really important versus what is yeah, so I would make sure that it's cleansed in a way where it's obfuscated. You're not exposing personal information where PII is at risk or HIPAA is at risk, because there are always ways for you to, because even marketing media and other businesses that I've worked with in the past, you've got to be able to run your data somehow, right, and be able to do something with that gets exposed in some way. And so you've got to be able to strip everything out and make it anonymous before you do something with it. And I would go even a step further, because there are different tiers of types of sensitivity of data within an organization, right? There is some data that you're just going to say we can't expose this, right? So you got to find another way to be able to work B2B securely and to make sure that you don't expose that side of the business, but you have others where you can share a little bit more freely. So hopefully that answers your question.
Hi. First of all, thank you so much for your presentation. I'm actually intrigued with the concept of Raft. Specifically, somehow I never met a person who had actual experience with Raft. Did you, in your consulting experience, have a chance to actually use Raft? And if yes, could you navigate? Probably, okay.
It was something that I found that I thought was actually really interesting, and I wanted to be sure that you guys heard.
Sounds cool, but reality is no one actually tried it.
Yeah.
Okay, cool. Thank you.
That's it.
Oh, I was going to piggyback on a conversation.
Okay.
Really quick. I'm going to chime in on the conversation that this gentleman started and you replied to. So if you're working with stuff like JSON, one really good library to use if you haven't used it yet is Pydantic. And then as far as performance goes, some models are much better at working with JSON than other models are. Specifically, what we found with the publicly available models, ChatGPT by far is way better. So like, if you use Llama, it's notoriously chatty, but ChatGPT is much better with machine readable use cases. And then so what you want to do is generate something and then run it through Pydantic configuration to make sure that you get what you expected. And then if you don't, regenerate and then do that. And that worked pretty well for us.
All right. Make sure y'all connect during the networking time. Here we go. One more over here, and then we'll give my man Clement a rest.
Do you have an opinion on what base model works best with, like Mistral, Llama, whatever? Because we know ChatGPT 4 works, but we all want to deploy things in production where it doesn't cost money. So is there a model which works? But whatever.
I understand. I wouldn't be the right person to answer your question because I don't work at that level with those models, but I do know that there are plenty of models that are much smaller in parameters that are much more affordable. So even though you're not going with the free model, you can find something that is more economical and would probably give you the same level of results if you spend some time fine tuning from what I've read. But it takes a lot of experimentation. And from the papers that I read, people are always running different reports and showing how there are different levels of ranking based off of that level of fine tuning. So.
Okay, one more time for Clement. You from White Hat AI. I'm sorry, White Glove AI. Excuse me. All right. And all of our speakers will be here for the networking portion. Like I said, my favorite portion. And of course, between each other, we have a lot of smart minds in here. So feel free to connect with each other. And actually, on that point, a lot of the speakers that we have here are people who attended and just wanted to speak. So if you find yourself interested in coming up on the stage and spreading some of the understanding that you have about AI to the other people that are here, definitely get in touch with either myself, with Vlad, or Emily in the back there. Before we wrap up, Vlad, one more time, would like to say just a few words just before we release here.
But this time, I want to recognize tremendous efforts that made these events happen. I want all of us to say huge thank you to Emily, because without her, nothing like that would ever happen. Emily, you're awesome. You're literally awesome. Thank you so much for doing this. And guys, thank you for coming. And please come on April 23rd and please share your feedback about what happened today on LinkedIn and tag those people who you believe will benefit from coming here. And I was told that there is still beer and wine and beverages and a little bit of food left. So let's talk to our neighbors. Let's network. Let's chat. Let's basically meet each other. Thank you. Thank you so much for coming.